Okay, good morning. Today's lesson is lesson 41 on functions. So get out your notebook, write the title down, and we'll take notes. I have several examples. All right, so the formula of a perimeter of a square is P equals 4S. So write that down, formula for the perimeter of a square. And this is a formula. It's also a function because it identifies the relationship between two variables. The first variable, S, is the length of the side of a square, and the second variable is its perimeter. So this is an example of what a function is. All right, so let's look at some more examples of functions. Before that, let's define what a function is. So you'll need to have this in your notes. A function is a mathematical rule, so it's a rule that identifies a relationship between two sets of numbers. So write that definition down. A function's rule is then applied to an input number to generate an output number. So it's important to note that for each input number, there is one and only one output number. So write that down into your notes. In the formula, perimeter equals 4S, the input is the length of the side, that's the S, and the output is the perimeter. So perimeter will equal whatever 4 times the side is. So this is an example of a function machine. So you have an input that you put inside of the function, then the function does something with it, and you get an output. A function is described in words, or it can be in an equation, and then we illustrate it with tables and graphs. So that's important. A function is described with words, it can be expressed as an equation, and then it is shown in tables and graphs. And that's what we're going to be doing in this particular lesson, is finding functions and then creating tables and graphing them. This is an example of a table for our formula P equals 4S. Okay? So what we've done is we've taken the formula P equals 4S and then we've come up and made up some numbers. And we've inputted 1 into the formula. So if we input 1 into the formula, the perimeter equals 4 times 1, and that's how we get the 4. And if we enter 2 into our formula for S, 4 times 2, that gives us 8. And then if we enter 3, of course, we get 12. So this is a table that you're going to learn how to make. And then if you graph these are actually ordered pairs. So you have points 1, 4, that comes right here. And then you have 2, 8, and then you have 3, 12. And you know how to graph, so I'm not going to review that. But then you have these particular points. And then it represents a relationship, and we draw a line through it. So you want to have this particular graph in your notes. And this is a linear relationship because when you graph it, it forms a line. All right, in this lesson we're going to consider some other function tables and graph some functions. Example 1, put this in your notes. You have the perimeter of an equilateral triangle is 3 times the length of one of its sides. So we're going to use this information. We're going to write an equation that expresses the relationship. It says to use P for the perimeter and S for the side. Then we're going to choose 4 different side lengths. In other words, we're going to make them up. Then we're going to make a function table that shows the side lengths and the perimeters of the equilateral triangles. Then the last thing we're going to do is graph, and it tells us to let the horizontal axis be the S and the vertical axis be the P. So let's go. All right, it says to find the perimeter of an equilateral triangle, we will multiply the length of a side, S, by 3. So the perimeter equals 3 times the side, 3S. So this is our function, so that's the answer to A. Then it says we're going to input some numbers and make up some numbers. So we're going to let S, so here we have an S and a P for our table right here. We're going to let, when S equals 1, then P is equal to 3 times 1, so P is equal to 3. And then the perimeter when S is equal to 2, 3 times 2 gives me 6. And then we have 3 times 3, which gives me 9, and 3 times 4, which gives me 12. So now I have a table of values for our function, and then you want to graph them over here, so make sure you've graphed them. And this shows the relationship between the side lengths and the perimeter of an equilateral triangle. And then you'll notice when you graph them that all of these, it forms a line, right? So that means it's a linear relationship, because when you graph the points, draw a line through it, it creates a line, and that's called linear, L-I-N-E-A-R. All right, example 2, you have Javier and Yolanda, they're playing a game. When Javier says a number, Yolanda performs an operation with a number and says the result. The table shows 4 numbers that Javier said. This is Javier right here. These are the numbers that he said, 2, 3, 4, and 5. So write this table down. And then Yolanda, this is what Yolanda replies. She says 4, then she says 5, 6, and 7. Then it says, describe the rule that Yolanda uses and write the rule as an equation. Then you have to graph the XY pairs from the table and all other pairs of numbers that they could say. So the solution here is, you can see that 2 plus 2, that gives me 4. 3 plus 2 gives me 5. So it's x, whatever x is, plus 2 will give me y. So this is my equation, because you're adding 2 to the left side to get to the right side. Now we're going to graph this. So we have the rule. So if I graph this, I have these ordered pairs, 2, 4, 3, 5, 4, 6, 5, 7. So graph that in your notes. And it shows that all of these functions numbers fall on a line, so it is what I said before, linear. So the 2 examples that we just talked about are examples of linear functions, but not all functions are linear. Okay, so now we're going to talk about whether or not relationships are proportional. So proportional. We know that in order for something to be proportional, so write that down, proportional, then you have to take the output and divide it by whatever the input is. And if you divide the output divided by the input and you get what we call a constant, or the same number every time, then the relationship is proportional. So look at the example, and you don't necessarily have to write all of this down, but I want you to just try to understand it. So look at this. This is the perimeter equals 3 times the side, the one we did in one of the examples, the first example. So if I take the P, whatever the P is, and divide it by whatever the S was, that's the output divided by the input, I get 3 over 1 here, and so I get 3. 3 divided by 1 is 3. Here, if I take the perimeter, divide it by the S, the side, 6 divided by 2, I get 3 again. Here, if I get 9 divided by the 3, I get 3 again. And then the last one, of course, I'll also get 3. But if you look at example 2, even though it is a function, this function is not proportional, because if I take the y and divide it by the x, so the output divided by the input, I get 3 for the first one. But the second one, it's 4 divided by 2, so that gives me 2. 5 divided by 3, well, that gives me 5 over 3, or 1 2/3. And 6 divided by 4, 6 divided by 4 gives me 3/2. So the relationship on the right is not proportional, and the relationship on the left is proportional. Hopefully that makes sense to you. All right, graphs of proportional functions have 2 characteristics. This is important, so write this down. Graphs of proportional functions have 2 characteristics. The first characteristic is it has to be linear. In other words, it has to be a line. So when you look at a graph, if it's a straight line, then it could be proportional. The second requirement is that the line has to go through the origin. This is the origin where the x and the y meet. So if you have a line that goes through the origin, then it is proportional. If you have a line that doesn't go through, like this one does not go through the origin, but it is a line, it's linear, but it's not proportional. Okay, so let's go to the next example. All right, example 3. Here we have the area of a square is a function of its side length. The graph of an area function is different from the graph of a perimeter function. Here's the function. It's a equals side squared. That's how you find the area of a square. You take the side and you square it. So this describes that rule. It wants us to describe the rule with words and make a table that shows at least 4 pairs of numbers that satisfy the function. And then we graph it. Okay, so the function in words, a equals side squared, is here. To find a, square s, or square the sides. Here we're gonna choose 4 numbers for s, and the numbers are 0, 1, 2, and 3. So write this table into your notes. And then we're going to go and we're going to square 0. So I do 0, so area is equal to 0 squared. Well, that just gives me 0. Area equals 1 squared. Well, 1 times 1 is 1. So that's this one. Area equals 2 squared. 2 times 2 is 4. So that's that one. And area equals 3 squared, which is 9, right there. So now we have ordered pairs, and this table here shows our ordered pairs. You have 0, 0, so graph that there. 1, 1, which is here. 2, 4, over 2 up to 4 is there, and then 3, 9 is there. And then you want to draw a line through the graph. So you can see that the points are not aligned. It's not a straight line. It kind of curves right here. So, and it's getting kind of steeper and steeper. So this is not a linear function. Even though it does go through the origin, it's not linear because it's not a straight line. All right, I think we have 2 more examples. All right, example 4, get this in your notes. Janos is playing a numbers game. When Zena says a number, Janos says a number that is twice Zena's number. So we have to write an equation for this game, using x for the number Zena says and y for the numbers Janos says. Then we're going to make a table, and then we're going to graph it. Okay, so when Zena says a number, Janos says a number that is twice Zena's number. Okay, so the output is what Janos says. So let's look. All right, so here is our rule. Y equals 2x. So 2 times whatever he says will get our output. So that's our rule. Then we're going to create a table like this, and we're just going to make up some numbers. This time we made up numbers 0, 1, 2, and then we threw in a -2 just for fun. All right, and then whatever, so then we're going to find out what y is. So if I do 2 times 0, I get 0. 2 times 0 gives me 0. Then 2 times 1 gives me 2. 2 times 2 gives me 4. And 2 times a -2 gives me a -4. So this is my table of values. Then you're going to graph it, and you should know how to graph. Draw a line through it, and then tell me, is this proportional or not? Yes, it is proportional because it meets the 2 rules that we need, and that is it has to be linear, right? It has to be a straight line, and then it has to go through the origin. And you can see here that it's linear and it goes through the origin, so the relationship is proportional. Okay, this is our last example. We're going to graph the function y equals 1/2 x minus 2. So that's all we have to do. There's no game, there's nothing, it just gives us the function. So what we need to do is to be able to graph the function. In order to graph it, we need ordered pairs. So in order for us to have ordered pairs, we're going to have to make up some numbers for x and put them into our function, find an output, and then graph it. So let's do that. Okay, so make a table, and we're going to let x be 0, 1, and 2. We're making up 3 numbers. Then we're going to take our equation, our function, 1/2 x minus 2, and I'm going to substitute my x there and solve. So I do 1 equals 1/2 times 0 minus 2. So that is 1/2 times 0 is 0, so I get 0 minus 2, that gives me negative 2. So y would be negative 2. Then I'm going to substitute 1 where the x is, 1/2 times 1, so I put a 1 where the x is, minus 2 equals, so 1/2 times 1 is just 1/2. 1/2 minus 2 is equal to negative 1.5. And then I can do y equals 1/2 times 2, 1/2 of 2 minus 2. Well, 1/2 times 2, if you do 2 over 1, that cancels. You just get 1 minus 2, which is negative 1. So my y values would be negative 1.5 and negative 1. If I did that right. I'm going to check my work on the next page. Hopefully I subtracted right. And you'll catch me if I didn't. So let's go on. Okay, well look, they chose different numbers than I did. So they got 0, which was a negative 2. So 1/2 times x, 1/2 times 0 minus 2, that did give me a negative 2, so they got that point. Instead of using the 1, they just did 2, so they got a negative 1. So 1/2 times 2 is the same thing we just did. Minus 2 equals negative 1. And then they did 1/2 of 4. Well, 1/2 of 4 is 2 minus 2, and they got 0. So they have these points right here. So graph those points. And then tell me about this. Is this linear? Yes, it is linear. So write that down that it is linear. Is it proportional? Is this a proportional graph? It is not proportional. And why? Because it does not go through the origin. All right, that's it for now. We will talk more about this in class if you don't understand it, and you can always ask the teacher. So I hope you guys have a great day, and I guess we're on to the written practice, or the practice set. I guess you have to do that first.